Alright, we are on the back of 11.2. We're going to start adding polynomials without algebra tiles. So there are two methods for this, the horizontal method and the vertical method, and I'll show you both. You can use whichever one you want. But the horizontal method is just looking at them side by side and picking out the like terms and adding them. So we are adding polynomials. It's important that this is a plus sign, because if that's a minus, then something else has to happen. This is a plus, so now we can just add up our polynomials. Well, to add these, we have to combine their like terms. So I see a 4x squared. I'm going to put a box around it. Any other time I see an x squared, its like term, I'll put a box around it. So that is x squared. So I'm going to add the 4x squared and the x squared. What else can we add? I see a positive 3. Does it have a like term? Yes, the positive 5. So I'm going to take that positive 3, the positive 5, and those are like terms. And the negative 3x, that doesn't have anything to combine to. So now let's go ahead and start combining. I have 4x squared plus x squared, which we know has a 1 in front of it. So I have 4x squareds. I add 1 to it. That gives me 5x squared. Combining like terms. Now I have a plus 3 and a plus 5. 5 plus 3 gives me 8. Lastly, I have that negative 3x. So instead of the plus, I actually want minus 3x. Before we're finished, we've got to put this in standard form. So remember, if this is going to be in standard form, we have to have decreasing order of exponents. So 5x squared does have the greatest degree. 5x squared goes first. Then negative 3x has the next degree. It's got a degree of 1. And then that positive 8 goes last because it's the constant. So when we're adding them, we always put them in standard form before we're finished. So that's horizontal. Just pick out the like terms. Vertical, that's going to be us lining them up on top of each other. So first thing I'm going to do is write 10y squared plus 6 plus 8y in standard form. So I know the y squared comes first, then the y term, then the 6. So write it in standard form. Now we're going to take this one and line it up with the appropriate terms underneath it. So that negative 11 goes underneath the 6. That 17y squared goes underneath the 10y squared. And that negative 12y goes underneath the 8y. Well, now what we can do is just add it up. We just add them up on top of each other. 10y squared plus 17y squared gives me 27y squared. Then I have 8y minus 12y gives me negative 4y. And then I have 6 minus 11, and that gives me negative 5. Is this in standard form? Yes. I have the y squared, the y, and then the constant. So this is finished. So those are the two methods. You can use whichever ones you want. I want you, well, no, I'm going to look at number 3 with you, and then you can try 4 on your own. So number 3, you can use whatever method you want. I prefer the horizontal method, so that's going to be the one that I tend to use. This is a plus sign in between them, so now we can identify our like terms. Notice on this we have x squared y, we have xy squared, and x squared y. xy squared and x squared y are not like terms. We have to have the same exponents on x, same exponents on y. So xy squared does not equal x squared y. Just a side note. Well, let's look at negative 2x squared y. Does that have any like terms? Anything we can combine? Yes, I see another x squared y. So we can add those up. Well, that negative y squared, is there anything that goes with that? Yep, there's the 4y squared. Notice that I circled the negatives with these. That's important. Now this 3x squared y doesn't have anything to combine, so we just leave it. So let's start combining. Negative 2x squared y plus x squared y. So I have negative 2 of them. I add 1 to it, and that's going to give me negative x squared y. Now I have negative y squared plus 4y squared. Negative 1 plus 4 is going to give me positive 3y squared. We just add their coefficients. And then lastly, this 3xy squared didn't have anything to be combined to. Well, is that in standard form? No, it's not. Remember, for standard form, we have to put them in decreasing order of degree. So this degree is 3, this degree is 2, and this degree is 3. Now, these have the same degree, so how do we know which one comes first? Alphabetical order. Same degree, now we choose the one with more x's. So that negative x squared y is going to come first. Now we're going to write our 3xy squared because it also has a degree of 3. Lastly, we've got 3y squared. Okay? I want you to go ahead and try number 4 on your own, and then start the video back and check it with me. Let's look at number 4. No matter what method you use, you should get the same answer. So I'm going to use the horizontal method again. 5x, does that have any like terms? Yes, it has the 3x. So I'm going to put a triangle around them because they're like terms. 5x and 3x. 6x squared y, does that have anything to combine it to? Yes, I can combine it with the 10x squared y. So I'm going to put a square around this one and make sure you include that negative. Negative 3, it is like terms with the 7 and the negative 4xy squared, no like terms. So let's start adding up the things that have the same shape, the like terms. 5x plus 3x, we add the 5 and the 3, that gives us 8x. Now we have 6x squared y minus 10x squared y. 6 minus 10 gives me negative 4, and then x squared y. Now negative 3 plus 7, that gives me positive 4. And of course negative 4xy squared, nothing to combine it to. Well, let's put this in standard form. We need to look at the degree. This has a degree of 1. This has a degree of 3, degree 0, degree 3. Remember, same degree. Now we do alphabetical order. So this one has more of the x's, so negative 4x squared y will come first. Then we bring that negative 4xy squared. Next we bring the 8x and the 4. So now we added them and we put it in standard form. So that's adding polynomials. Just find the like terms and add them together. Before we're finished with adding, let's look at these questions. First question, are the answers to each of the problems above polynomials? Are all of these 4 answers polynomials? And the answer to that is yes. How do we know that they are polynomials? They have whole number powers. Remember, whole number powers, they have to be positive, they can't be fractions, and they can't be decimals. All of these have positive, non-fraction, non-decimal powers. So yes, they are all polynomials. So next question. Is the sum of 2 polynomials always going to be a polynomial? And if so, what does that mean? The answer to this is yes. Whenever I add 2 polynomials together, I will always get another polynomial. And this means that polynomials are closed under addition. They are closed under addition, and that just means if I take any 2 polynomials and add them, I will always, always, always get another polynomial. Okay? So let's go ahead and look at subtracting polynomials. To subtract a polynomial, you add its opposite, or you just subtract each of its terms. So I'll show you what that means. Again, we've got horizontal and vertical methods, but this time before we do anything, we have to take care of this negative sign. Remember, negative and a minus sign are the same thing. I'm subtracting, so before we proceed, we need to take this subtraction and distribute it to everything in these parentheses, only the second set of parentheses. So the first set, 2x cubed plus 8x squared plus x plus 10, that remains unchanged. I just copied that down. Well, now I have negative times 5x squared, that gives me a negative 5x squared. Negative times negative 4x gives me a positive 4x. Negative times 6 gives me a negative 6. So you have to distribute it first. Now that we've done that, we can combine our like terms. So 2x cubed, I don't see any other x cubes. 8x squared, we can combine that with the negative 5x squared. I see positive x, that can be combined with the positive 4x. And then positive 10 can be combined with the negative 6. So we're just adding our like terms. Well, 2x squared, nothing to do with that one. 8x squared minus 5x squared. 8 minus 5 gives me positive 3. Positive x plus 4x, we know that's a positive 1x, so 1 plus 4 gives me 5. And then 10 minus 6 gives me 4. Well, this one actually happens to already be in standard form. X cubed, x squared, x, and the constant. So we're good. There's the horizontal method. Now let's look at the vertical method. The first step you still have to do is distributing that negative or that minus sign. So let's go ahead and start with this one. We're going to go ahead and write this one out in standard form. So 14x squared plus 5x plus 12. We're just rewriting it in standard form. Now when we bring all of these and write them lined up below, we need to go ahead and distribute. So negative times a negative 7x squared is going to give me a positive 7x squared. Negative times 15 is going to give me a negative 15. And negative times 8x is going to give me a negative 8x. So now we can add these together. Once we've gotten rid of the subtraction, we can just add them. So 14x squared plus 7x squared will give me 21x squared. 5x minus 8x, the 5 minus 8 gives me negative 3x. And 12 minus 15 gives me negative 3. And that is already in standard form, x squared, x constant. So for the next two, you can use whichever method you want to. So I'll do number 9, and then we can do 10. You can do 10 on your own. So number 9, first thing we have to do is distribute that negative. So we have 2x squared y plus 3xy squared plus 2. Now, negative times a negative gives me a positive 5x squared. Negative times a negative gives me positive 2xy squared. And negative times a negative gives me positive 9x squared y. And now we need to combine our like terms. So 2x squared y, we can add that with 9x squared y. 3xy squared can be added with 2xy squared. And then the 2 has nothing to add to. 5x squared has nothing to add to. So let's go ahead and add them up. The 9 plus the 2 gives me 11x squared y. 3xy squared plus 2xy squared gives me 5xy squared. Then we have 2 and 5x squared. Last thing we need to do is put these in standard form. So this has a degree of 3, degree of 3, degree 0, and degree 2. So that means between these, we've got to put the one that has more of the x's because they have same degree. Higher x is the x squared. So that goes first, then our x squared y plus 5x squared plus 2. Go ahead and try number 10, pause the video, and then start it to check your answer. All right, here's the answer to number 10 with my work. Go ahead and pause the video if you need to check the work. But just briefly what I did, I distributed the negative, I circled or squared my like terms, added them, put it in standard form. Okay, last two questions. Are the answers to numbers 5 and 6, that should say numbers 7 through 10, are these all polynomials? Just like in addition, yes they are. How do we know they're polynomials? They have whole number powers. So based on what we said with addition, because all of these are polynomials, what does that mean? Is the difference of two polynomials always going to be a polynomial? Yes. And that implies that polynomials are closed under subtraction. All right, make sure you answer all the questions on this little quiz and submit it. And once you finish, head to Delta Math, and then you can work on your homework.